Welcome to the fourth and final video of this fourth module in our MOOC on EU space governance. This final video will focus on the EU and space sustainability, and it will address the critical aspects of maintaining sustainable space operations and how to mitigate the environmental impact of space activities. Now, in this video, we will explore the challenges to space sustainability. We'll discuss the EU's approach to managing sustainability in space in its internal policy. We'll also examine the EU's international initiatives to promote space sustainability. And we'll highlight how space supports the environmental policy objectives of the European Union as well. Now, space sustainability encompasses two critical dimensions: sustainability in space and the sustainability of space activities on Earth. First, sustainability in space. This dimension primarily concerns the creation and management of space debris. Space debris includes defunct satellites, spent rocket stages, and importantly, fragments from disintegration, erosion, and collisions between different space objects. These remnants pose significant risks to active satellites, to space missions, and to human spaceflight. Now, the crowded environment of Earth's orbits, and particularly LEO, low Earth orbit, heightens the probability of these collisions, which then in turn can generate even more space debris, and that ultimately would result in a cascade effect that is known as the Kessler syndrome. The second dimension concerns the sustainability of space activities on Earth. So this dimension really addresses the terrestrial impact of space activities, and it focuses on the environmental footprint of the space industry. Key issues to address here include the sustainability of supply chains for space, but also emissions from rocket launches and the use of hazardous materials in the construction of space objects and infrastructure. So the extraction and the processing of raw materials, manufacturing, and the disposal of space-related components all really contribute to environmental degradation on Earth. Additionally, rocket launches emit large quantities of greenhouse gases and particulate matter, which affects air quality and ultimately contributes to climate change. So a comprehensive policy on space sustainability should contain action on both these dimensions of space sustainability. And the EU clearly recognizes this, but still its internal policy has mainly been developed with a focus on the first objective of sustainability in space. The development of the EU SST service is or was a significant step towards this goal because it provides crucial data for collision avoidance and debris tracking. But in addition, the EU has also worked towards establishing a common approach in recent years to space traffic management, or STM. STM has been defined by the European Union as the means and rules to access, conduct activities in, and return from outer space safely, sustainably, and securely. It relates to different elements, including space situational awareness, or SSA activities, which includes SST, or space surveillance and tracking. It also refers to orbital debris mitigation and remediation, as well as management of space orbits and the use of radio frequency spectrum for this purpose, and the entire life cycle of space operations, which goes from the launch phase to in-orbit operations of spacecraft, and finally end-of-life deorbit, but also re-entry operations of space objects. Now, in 2022, the European Union established a common approach to space traffic management. And this approach is detailed in the joint communication of the European Commission and the High Representative on an EU approach for space traffic management. This communication outlines several specific objectives and actions to enhance the safety, security, and sustainability of space operations. The key actions of this EU approach to space traffic management include, first of all, enhancing EU operational capabilities to support space traffic management. So to perform STM activity that's necessary to really be able to observe space traffic continuously. And this requires further improving the performance of the existing services of the EU's SST partnership, but also developing new technologies to tackle these increasing STM requirements. Secondly, it involves fostering STM regulatory aspects as well. So in addition to the operational improvements, both binding and non-binding space traffic management rules should be adopted, first of all, at EU level. And this includes rules for the monitoring, development, and promotion of European STM standards and guidelines, but also actions to incentivize respect by all players for these ultimately non-binding rules, as well as in the end a proposal of a limited set of binding STM obligations. Third and a final set of actions focuses then on promoting the EU's STM approach globally. Setting higher standards of space sustainability within the EU only is a first step, but it would ultimately hamper really the competitiveness of the European space industry. So the EU therefore also aims to promote its internal rules on STM in international forums, such as UN COPUOS, but also in bilateral discussions with key partners in space, such as the US. Now we'll discuss this international dimension of the efforts of the European Union to promote sustainability in space in the next section. But first, the question is, where does the EU stand on the sustainability of space activities on Earth, this second dimension of space sustainability? As I've mentioned, policy in this area is a bit less developed currently, but the forthcoming EU space law is expected to change this to a large extent. So that law may be expected to include some detailed provisions on varying topics of space activity sustainability, which can be borrowed from other policy fields. This might conceivably include, limiting emissions from launches to ensuring sustainable supply chains. And these rules would likely be in addition to a set of specific rules in the EU space law that would like to turn currently non-binding guidelines on space traffic management into a binding set of STM obligations, as is proposed by the 2022 EU's STM communication. Now, the EU, as we know, is an increasingly active external actor in space. This also goes for the facet of space sustainability. Now, one notable initiative here was the European Union's proposal for an international code of conduct for outer space activities, or ICOC. The purpose of this code was to enhance the safety, security, and sustainability of all outer space activities, as well as of the space environment itself. And it would do so by setting a number of TCBMs, transparency and confidence building measures that would apply to the entire international community. Now, although this proposal for an ICOC, an international code, was non-binding, the initiative ultimately did not succeed. And the last draft of the code has not really been discussed in international circles since 2014. Still, it demonstrated the EU's commitment to fostering a responsible behavior in space. And the EU really continues to show this commitment in various other ways to this day. And it mainly does so by supporting and really substantially contributing to international guidelines and frameworks on space sustainability. And although, yes, these are again non-binding rules, guidelines such as this can still have a clear impact on how policies and regulations, including binding regulations of the European Union and its member states, may and will evolve in the next coming years. Now, in this respect, we can first refer to the European Union's support for the IADC guidelines on space debris mitigation. These guidelines were proposed by European Space Agency as well as other national space agencies in the Interagency Space Debris Coordination Committee, or IADC, and they were later endorsed by the UN General Assembly. These guidelines provide recommendations for minimizing space debris generation. They include best practices, essentially, for satellite and flight disposal and measures to reduce the risk of in-orbit collisions. And of course, this contributes to long-term sustainability of space activities. In this respect, a comparable initiative are the guidelines for the long-term sustainability of outer space activities, or LTS guidelines. Now, unlike the IADC guidelines, which were developed by a set of space agencies, these LTS guidelines were, from the get-go developed by UN COPUOS, and their aim is to is also a bit broader than debris mitigation, actually. This is also implied by the name, right? The LTS guidelines really aim to ensure the long-term sustainability of space activities overall, rather than just focusing on debris mitigation. So they encompass a broad range of practices, ranging from, yes, debris mitigation, but also design of spacecraft to the entire conduct of space operations in general, all of which, again, are aimed at promoting the responsible use of outer space. Finally, and most recently, member states of the European Union have unilaterally committed not to conduct destructive anti-satellite, or ASAT, tests. So over the past decades, various countries, as we've mentioned, including China, Russia, but also India, have conducted such ASAT tests to demonstrate their military capabilities, but it drastically increased really the space debris population in already crowded Earth orbits. And the EU member states' unilateral declaration not to conduct these kinds of tests really demonstrates the willingness of both the European Union and its member states to take action on a number of issues that proved too contentious during the discussions on the LTS guidelines, for example, to reach broader consensus and move forward and beyond those commitments in the LTS guidelines. Finally, the European Union also leverages its space program to support environmental policy objectives. This, of course, is an important way in which the European Union aims to realize its ambitions under the so-called European Green Deal. So space-based data and services, of course, play a vital role in monitoring and addressing several environmental challenges. And for the moment, we'll just name a few here. First of all, climate monitoring, right? Satellites provide critical data for the European Union to monitor climate change, to track greenhouse gas emissions, and to really assess the impact of its own climate policies. Secondly, disaster management, right? Space-based technologies enhance the European Union's capacity to respond to natural disasters, which improves resilience and ultimately recovery efforts in case those disasters strike. Thirdly and finally, biodiversity protection. Satellite imagery and data supports the efforts of the European Union to protect biodiversity, to monitor changes in land usage, and to really manage natural resources sustainably. So in conclusion, the European Union's comprehensive approach to space sustainability addresses both the sustainability of space and their activities in space, but also the impact of space activities on Earth, albeit with a focus, as we've mentioned for now, on the first part. Now, through both internal policies and international cooperation, and also by leveraging space technology for environmental goals, the EU is really working to ensure that space remains a sustainable and accessible domain for future generations. So thank you for your attention. We invite you to join us for the next module of this MOOC, which will shift away from the policies of the European Union and go a bit deeper into the economic, industrial, and market framework of EU space governance.